we're going to start the last section of calculus, which we call integral calculus. So what I want you to think about when you see integral calculus, think antiderivative. For example, if f of x is equal to 2x plus 3, then what the derivative does, f prime, is simply gives us 2. Well, what the integral does is, let's start with 2, and this is the symbol for integral. Let's go the other direction. So the derivative of what is equal to 2? Well, there we go, 2x plus some constant. So the derivative takes us one direction and the integral takes us the other. Let's look at another example. So let's take the integral of 2x. Oh, we just did that. So let's do something a little bit different then. My bad. 2x squared. There we go. dx. Now the reason we put dx is to distinguish that x is our variable. We'll explain what that means a little bit later. So what we want to know is, what is the derivative of something that equals 2x squared? So we take the derivative of f of x, which is something we don't know, and f prime of x is equal to 2x squared. So we want to go this opposite direction. Well, let's think about this. 2x squared is our answer. So that way we know f of x has a power, because remember, if we have axn is f of x, then f prime is equal to n times axn minus 1. This was the power rule. So therefore, if we want to go the opposite direction, we need to add 1 to the exponent. So f of x here starts off with x cubed. Now a stays, so the constant stays. And now as we bring that 3 here, it needs to cancel out with something in the bottom to equal 2x squared. And now we add c. So the integral of 2x squared is 2x cubed, 2/3 x cubed plus c. Well, let's see if we find that. Let's take the derivative of 2x cubed, or 2/3 x cubed plus c. Well, that is equal to 3 times 2/3 x squared plus 0. These cancel. That equals 2x squared. So if that doesn't make sense yet, let me write an equation which you're going to hate and not like, but hopefully it'll explain things a little easier. So the integral of kx to the nth power of dx is equal to, well, let's start with the x. When we take the derivative, we subtract off 1. So when we take the integral, we just add 1. The constant stays out front, and because we're bringing when we do the derivative, the exponent down in front, when we do the integral, we bring it underneath, plus c. So this here is the general rule of how to do an integral. Let's briefly look at an example. So let's look at 5x to the 6th and take the integral of this. So applying this rule, I'm going to start with x. So it was 6, but now I need to bring it to the 7th power. The 5 stays there, and now that power just goes to the bottom, plus c. And that is an application, and that there is my final answer of the integral of 5x to the 6th.